Okay, so let's give you guys a line integral exercise. So we've got a surface. So we've got this surface, and your job is to work out the line integral. Your job is to work out the line integral along this particular path, starting at this point, and moving along to this point. So your particle is moving along like this, which means your particle is moving along like this. And as the particle moves, you always need to jump to this surface. So when the particle is here, you will jump to the surface here. And then when the particle is here, you will jump to the surface, So really, I'm asking you to work out the area underneath this surface along this particular path. So work out this area here. Okay, so press pause and have a go. Okay, so to do this, we need to work out the speed of the particle as it moves. As it moves along, well, we need to find a way of driving the particle along this particular path. So set up your parametric equation. So let's set it up as this. So you start out at this location, 1, 2, and then stick a T in here, and you're going to move 3 across and 5 up. 3 across and then 5 up. So you're moving 3 across and then 5 up. So from here, that will allow you to come up with your parametric equations, and T ranges from 0 to 1 because we set it up in such a way that in 1 second you would have moved 3 across, 5 up. So T ranges from 0 to 1. Anyway, your parametric equations will be given by this. From this, you can come up with your position vector. So your position vector is given by this. So what that means is, as time ticks away, you always know the position vector of the particle. So the particle is moving. You always know the vector from the origin to the position of the particle. So anyway, your position vector is given by this. And remember, in order to work out the line integral, we need to know the speed. So from your position vector, differentiate it once. That will give you your velocity vector. And then once you've got your velocity vector, use Pythagoras to work out your speed. So square this, and then take the square root. So your speed is given by this. So we can put this into here. Okay, so hang on. So we can put this into here. That will then give us this. And remember, T ranges from 0 to 1. From 0 to 1. And we always know the x and y location of the particle as it moves along that path. So we always know the x and y location. We will need to jump to the surface. So hang on, let me illustrate it. So as the particle is moving along that particular path, suppose the particle is here, you always need to jump to the surface. So you jumping to the surface is really you doing this. It's you doing this. You need to put this into the x, and we always know the y location of the particle. We need to put it into here. That will then give us, this is our y and this is our x. So this is really us jumping to the surface. So we are now currently here. We need to integrate it from 0 to 1. So this is a constant, so let's drag it out. So that will then give us this. And to integrate this, we will need to use integration by parts. So imagine this as u, imagine this as v prime. So integration by parts, it would be u times v. So this is u stays the same. And when you integrate v prime, it would be this, and then you've got to times a third, and then evaluate it from 0 to 1, and then the second part of integration by parts would be take away the integral from 0 to 1, and then it would be u prime times v. So u prime times v would be this thing here. We need to integrate it from 0 to 1. So now this is slightly easier to integrate. So integrate this, it will then give you this from 0 to 1. And then, hang on, and then evaluate it. Put 1 into here and into here. That will then give you this thing here, and then put 0 into here and into here. It will then give you this, and do the same over here. Put 1 into here. This will be to the power 4. Put 0 into here. It will be to the power 1, and that will then take you to here, and then it's just a matter of tidying this up. So it's blah blah blah. The final answer is this. This is your area underneath that surface along that particular path. Okay.